Okay, this is the theory part of what curvilinear kinematics. Uh, so we're just gonna get into that. Okay, I've got the questions here. There are 3 questions, including and 7 questions total. Okay, for practice today. I didn't say this in the first video. I probably should have, but I would recommend doing the questions yourself and then watching me do them, or just skipping to the final answer to check if you've done it right. Um, I mean, it's up to you, or you can like go along with how when I'm doing it during the process. Whatever's better for you. Okay, so question 1. The curvilinear motion of a particle is defined by Vx equals 50 minus 16t. Okay, so V is a function of t, and y equals 100 minus 4t squared. Y is also a function of t. This is useless information. X equals 0 when t equals 0, and then we want to plot the path and determine its velocity and acceleration when the position y equals 0 is reached. Okay, so this is fairly straightforward what we're looking for. We have v of x is equal to this, and we have y is equal to this. Oh, that's not meant to have a gap. Y is equal to this, right? So this is split into x and y. What are we looking for? We're looking for the path, the velocity, and the acceleration at y equals 0. Okay, so to get x, we start off by integrating v of x. So we just go x is equal to integral. I will fix some notation stuff later. X is equal to integral of 50 minus 16t. So x is equal to 50t minus 8t squared plus c. Right? But we know from our initial conditions here, x equals 0 when t equals 0. So plug in t equals 0. So x of 0 is equal to 0, which is equal to c. So c is just 0. So we can erase that from our equation. We have an x equation, we have a y equation, right? And acceleration is the opposite, by the way. The x acceleration, so a sub x, is just going to be the derivative of velocity. So we're just going to go d, or I'll do it like this, prime, right? And so a of x is equal to negative 16 meters per second squared. I should be writing that. Meters per second squared. All right? And now we look at the y direction. Okay? We take our equation here. We have v of y is equal to this prime. So v of y is equal to negative 8 meters per second. Negative 18 meters per second. Okay? Nice and straightforward. And then a of y, I'm not going to rewrite it again, but it's the derivative of the velocity, so it's just negative 8 meters per second squared. Okay, nice and easy. We have all of these now on hand. Okay? Now we need to plot the path, by the way. Now a method that people like to use, right, is a table. Okay, they plot out a table like this. 3 values fit here: t, x, and y. And I feel like you can understand what is happening here with this. T is equal to 0. What do we get for x? X is equal to 0. We know that. That's pretty obvious. What is y when t equals 0? You go to your equation, it's 100, right? And then you do like t equals 1 and t equals 2 if you want. But you don't need all that. You can plug in t equals 1 into this. So it's be 50 minus 8, 42. And then plug it into this. 100 minus 4, 96. Okay, and then based on this, you can actually graph your 2 functions together, right? This is your y, this is your x, At 0, y is equal to 100. Right? At x equals 42, we're going to 96. If you were to plug in 2, you would actually get that it's increasing again, right? Like plug in 2, you get 100 minus 8 times 4. So whatever that is. I'm too lazy to do that in my head. And same thing here. You get 100 minus 16, right? So both the numbers get smaller. So it curves like this. Nice graph. That's the first part of the question done, where it asks to plot the path of the particle. Now, we need to find the velocity and acceleration when the position y equals 0 is reached. So that is really easy. We go back to our equations. We plug in 0 is equal to 100 minus 4t squared. And this is just solving an equation. So we get t. You go plus 4t squared, and then it's t equals 5 seconds. Okay, that's all there is to it. You don't need to do a lot of work for that. And now you're looking for the velocity at that point, which is, we look here, we have the velocity of x is this equation. So 50 minus 16 times 5, 50 minus 80 is, so v of x is equal to negative 30 meters per second. And v of y, we look at our equation for vy, negative 8t, so it's going to be negative 40 meters per second. And then our accelerations are constant. We have negative 8 meters per second squared in the y direction and negative 16 meters per second squared in the x direction. And that's the question. Nice and straightforward question. Very easy. Yeah. Okay. Next question is going to be this one. We're looking at this question. A long jumper approaches his takeoff board A with a horizontal velocity of 30 feet per second. Determine the vertical component Vy of the velocity of his center of gravity. At takeoff for him to make the jump shown, what is the vertical rise h of his center of gravity? As you can see here, the distance traveled is 22 inches horizontally. Okay, his horizontal velocity is 30 feet per second. We're looking for Vy, and also we're looking for h from his center of gravity. So we're taking this as our datum. This is our 0, right? This is our 0. So let me just write out 2. This is Q2. Ooh, this is Q2. Let's get started with that. So this one's pretty easy. We want to get the time. So we go v is equal to d over t, which is just our velocity in x is 30 feet per second. To the left, by the way. To the left. We can take left to be positive, though. I will define left. You should always define your positives, just to keep track. This is my positive. I'm taking left to be positive, right? So we're going to have 30 is equal to 22 over t. So just flip it around. 22 over 30 is equal to t, which is equal to 22 over 30 is 0.733 seconds. Okay, that's the time it takes for him to make this jump. Now we will be switching over to the y direction. So that's how these questions work, right? Oh, that's not the right one. This is how these questions work. You start in one direction, okay? Either horizontal or vertical, depending on what you can do with the information given. You solve for something you can plug into the other components, usually time, mostly time, or distance sometimes, if you can, like, I don't know. Mostly time. You're solving for time, and then you flip to the next direction. So this is our horizontal, so let me write that down. Now we're moving on to our vertical, right? So what do we have in terms of vertical information that we can use? We have that we're looking for h. So we're looking for distance. We have time. Looking for distance, we have time. And we're on Earth, so we have gravity, g, right? So we have t equals 0.733 seconds. We have a is equal to negative, and this is in feet, by the way. Keep that in mind. 32.2 feet per second squared. And we have, remember what was said in the theory video, VF, right, is equal to 0. This is 0. His velocity here is 0. At the peak of h is 0. Keep that in mind. So we have 3 values. And what are we solving for? Vy at takeoff. So initial velocity. We look at our equations. What do we have that lets us solve for initial velocity with these 3 things? This top equation. V is equal to V naught plus ACT. Okay? Nice and easy. So V is equal to V naught plus AT squared. Plus AT, not AT squared. Oops. So this is easy. 0 is equal to V naught minus 32.2, 0.733. Flip your signs and multiply by 32.2, your time value. You will get that V naught, also known as Vy, so I'm going to change this to Vy because that's the notation in the question, is 23.6 meters per second. Right? Nice. Not meters per second, feet per second. Feet per second. Wait. Okay. Quick correction. This is meant to be over 2, right? This is the maximum time. If we bring up our diagram again, that's the time for him to go up and then back down. I made a little error. I apologize for that. So to get to the peak, that's only half the time. It takes half the time to go all the way up. And all the way down is the full time. So what you actually want to do is divide this all by 2, which gives you your actual answer of 11.8 meters per second. Okay. And now we want to solve for h using another equation. It doesn't actually matter which one you use between these two. Whichever one you prefer, they both will work. I'd probably use this one, I guess. Nice and easy. So no need to worry about it. V squared is equal to Vy squared plus a 2a, and then it's going to be h. We're using h in this case for notation. H minus h naught. Plug in the things that are 0. So you have 0 is equal to 11.8 squared plus 2 negative 32.2 h, just like that. Calculating for h is going to be pretty easy, and you're going to end up with an answer of h is equal to 2.16 feet. Okay. I apologize for the calculation error earlier, but it's okay. That's been dealt with. Anyways, on to Q3, we have this one. And let me just get rid of this. We have this one. This is Q3. This, again, is not that bad of a question. You need to set up a datum, choose your directions, which is positive and stuff. But let's read the question first. The barrel of a rifle is shown pointing at A, right? Compute the distance, delta, below A to the point B, where the bullet strikes. The muzzle velocity is 600 meters per second. So that's saying, and we have an angle of 20 degrees here. Keep that in mind. Angle of 20 degrees. So I'm going to define up to be positive and right to be positive for this question. And in terms of my datum, I'm going to set it right here at the muzzle. We know that the total distance horizontally is 1,000 meters. And we're looking for distance delta. So basically, we're going to be assuming an ideal case versus what actually happened, right? So let's get started. First things first, we know that delta, I don't think I have lowercase delta on my thing. I can check quickly. Lowercase delta, S del. Okay, I do. Delta is A minus B, right? So keep that in mind. And if we look at the picture again, delta is A minus B. Or you could do, yeah, whatever, A minus B. So we need to find the height A and the height B and then subtract them. Nice and easy. So to do this, we will be, well, we have a triangle, right? If we just look at this, 90-degree angle extends all the way to here, hypotenuse here, right? So we have a triangle, and I will draw it here, where this is 20, and this is A, and this distance here is 1,000, right? So to get height A, I'm going to go back to typing for that. To get height A, we're going to be using a trig function. And if you see, we have hypotenuse and we want opposite. So use tangent. It's going to be 1,000 tan 20. This is in degrees, by the way. So make sure if you're using a calculator, make sure it's in degrees and not radians. Because if it's in radians, you're not going to have, well, you're not going to have the right answer. So, yeah. Now, for point B, we're going to have to use a different strategy. Because if we actually look at this, this is not a triangle. This is curved. To get to B, it curved. So that means this is projectile motion. This was just trig, right? So we're going to go look at our projectile motion now. We want to get the distance, right? So we're going to start with some things. We know that the distance in x, so x is equal to 1,000. We know that v, just v, not vy, not vx, v naught is 600 meters per second. I should add in my things here, meters per second. And we know that we have a theta equals 20 degrees. I don't know. You know what? To the power of 0 is degrees for now. I should get a degrees hotkey. Anyways, so now we just need to calculate using trig again, because initially, as we've seen here, initially this is a triangle. It starts as a triangle. This is 20, right? This is 90. It starts as a triangle. We can get Vx, we can get Vy. So Vx is just going to be, so V sub x is just going to be 600, which is our hypotenuse, and we want adjacent to the hypotenuse. So we can use cosine 20, right? And then Vy is 600 sine 20. You need to know trig for this course. Make sure you know trig. That's very important to know trig. If you're weird, you can do cosine 70. Just use sine. I don't know why you would do cosine 70. I know it's like equal, but don't be weird. Be normal. Do it like this. Now we just need to calculate the time. Remember, we have v is equal to d over t in the x direction, horizontally. So we have our x, 600 cosine 20, which you can compute if you want to. I don't want to, so I'm going to leave it like that. Is equal to 1,000 over t, right? And we're looking for t, so we're just going to go 1,000 divided by 600 cosine 20. Put that in your calculator. Make sure you're in your degrees. Make sure you're in degrees. 1.773 seconds. Or I'll run to 1.77 because 3 significant figures. That's what I said. 1.77 seconds. That's your time to hit the wall. Okay, the wall is here. I should be using the other diagram, but whatever. The wall is here. The bullet's curving like this. It takes it 20 seconds to travel this 1,000 meters. Now we switch over to our height, also known as b. So b is our height. We're calculating height. We're going to use this equation. Ooh, it doesn't really matter. Actually, it does because we don't know the final velocity. We're going to use this equation, right? So back to it. B is equal to, well, we'll call it b naught. It's just 0. Doesn't really matter. Plus v naught t plus half a t squared. Plug in our values. B is equal to, what's v naught? 600 sine 20 plus half. Acceleration is negative 9.81. Negative 9.81. I forgot to write my time here. 1.77. And then 1.77 squared, which gives us a value that b is equal to 16.12. I mean, sorry. Wow. That was a mishap. B is equal to 347.85 meters. Right? We have A, now we have B. Now we're going back for delta. Right? So we'll just calculate that, which gives us a total final answer. Delta is equal to 16.12 meters. So that's saying in our diagram, B is right here. This distance, 16.12 meters. Another straightforward question. Very, very, very fun. Okay. Question 4 is going to be this one with the balls. Small steel balls fall from rest through the opening at A at the steady rate of 2 per second. So 2 balls per second are falling. Find the vertical separation h of 2 consecutive balls when the lower one has dropped 3 meters. So we're saying from A to here, this is 3 meters. That's what we're saying, okay? Neglect air resistance. You're going to do that all the time. Yeah. So fun stuff. Let's move on to the actual question work, right? One more thing to point out here is that they fall from rest at t equals, so that means at t equals 0, v is equal to 0. So v naught is equal to 0. Also, this is purely in y. Purely in y. Like, as you can see there, there's no x in the actual gravity motion. So what do you know? V naught equals 0. We can say that S naught equals 0. S equals 3. I'm going to call it positive. You don't have to do that if you don't want to. But you can. You can if you want to. T naught equals 0. What are we solving for again? I already forgot. 2 balls per second. Find the vertical separation of h. Okay. Nice. So T naught equals 0. A is equal to negative 9.81 meters per second squared. I should be putting units for things that aren't 0. What else do we know? That's all we need to know, actually. That's all we need to know. So looking at our equations, we have V naught. So check here. We have A, check. We don't have T, we don't have final velocity. Cross this off. We have A, we don't have T, so that's one unknown. We have S, we have S naught. Here we don't have final velocity, and we don't have, yeah. So we're going to use this middle equation. So I'll write that down. I'm going to keep it in terms of S. So S equals S naught plus V naught T plus half A T squared. Like so. That's our equation. Oh, and I should point out, this is T minus T naught. Don't forget that for all of these. I did because T naught is 0, so it doesn't actually matter. But this is how you should be thinking about these. It's always T minus T naught. It's not just T. It's just that in most cases T naught is 0. So that's why it's omitted on the formula sheet. But you should be thinking of it as a difference of final time and initial time. So we're solving for T. And if you can notice, we have 3 is equal to V naught is 0, right? So we have half negative 9.81 T squared. Like so. This is really easy to solve. So you're going to get t is equal to 0.782 seconds. And yeah. Wait. Or sorry, this is supposed to be positive 9.81 because I'm taking down to be positive. Yeah. Originally, that's not solvable. But it is solvable now, so that's good. Okay, t is equal to 0.782 seconds. So now that's for the first ball. I probably should have... Oh, I should have specified that. That's not the ball question. I don't know what I'm looking for here. That's not the ball question. This is for ball 1 we've just calculated, okay? So we got the time it took for ball 1 to get all the way down here. Okay? We need to get the position of ball 2. Yeah. There's a separation at a steady rate of 2 balls per second, right? So, yeah. We need, if there's 2 balls per second, that's 1 ball every half a second, meaning that for this, there's going to be a half a second, or you can see another ball has already dropped, right? Based on the picture. So that means half a second has elapsed here. You need to be looking out for these when doing these questions. So like it's saying, yeah, 2 a second, so 1 every half second. This is a full second of separation. And then this is a half second separation. If that makes sense. Because the second ball hasn't dropped yet here. Hopefully that made sense. It sounds a little nonsensical when I said it out loud. But, okay, we're going to look for the second ball. I should label this quickly. B1, and then ball 2, just labeled. We're going to look at the things. We have V naught equals 0, S naught equals 0. We have, again, acceleration is 9.81 meters per second squared. And I did forget to actually point out that this is positive. You should always do that, get into the habit of it. As you could tell I didn't get into the habit of it, but you should get into the habit of it. T is equal to 0.5 seconds. Okay. Or sorry, that's the time for ball 1. Right? We're looking for this separation here. That's the time for ball 1. The time for here to here is still 0.782. So we're just going to call that T of 0.782, right? And we're looking for SB, or just S in this case. It's going to be same formula, so I'm not going to bother copying it down. But we're looking for S is equal to 0, 0, half, 9.81, and then we have 0.782 minus 0.5, like so. S is equal to, this should be squared here, by the way. So that makes S equal to 0.39 meters. So now we're looking for H. If you look back at our problem, H is 3 meters minus wherever B is. And I know diagram-wise, this does not look like, this looks like 1.5 meters. But never trust the diagrams. They're never to scale. Diagrams are not trustworthy. Okay, they all suck, so don't trust them. H is equal to 3 minus 0.39, which is equal to 2.61 meters. That's H. I know it looks like it's halfway there, but it's not. Never trust the diagrams. Okay. Next question is actually not a picture question. So, yeah, it's this one. And I'm saving this number 3 for last because this question's like really long. Actually, I forgot to get like all the parts to it, but that's fine. Anyways, so this question. What do we see here? We have A, acceleration as a function of velocity, negative kv. K is constant, v is velocity. Initial velocity at time t is v naught equals 4 meters per second. And at time 2 is v equals 1 meter per second. Determine the time t, okay, capital T, and corresponding distance d for the particle speed to be reduced to 1/10 of its initial value. So we're looking for Vf is equal to v naught over 10. Okay, that's what we're looking for. We need to find time, right? We have acceleration, we have velocity, we have time. What does that make you think of? Acceleration is equal to dv dt. That fits everything, right? So we have negative kv is equal to dv, no, that's not equal, dv dt. So, well, from here it's pretty obvious what you would do. Negative k dt is equal to dv over v. That's cool, right? Integration negative kt is equal to ln absolute value of v. And in this case, you are actually doing a integration from v naught to v, the second velocity. And for t, you're integrating from 0 to 2, right? So keep that in mind. You're going to have negative 2k is equal to v naught is 4, v2 is 1. So it's going to be ln of, we can drop the absolute values, 1 over 4, right? Just like that. Solving for k, you would divide by negative 2 on both sides and then raise it to, or you don't need to raise it to anything. Divide by negative 2 on both sides. K is equal to 0.693. Yeah, so that's your k value. Now you have the constant, right? And now you just solve for the capital T, right? You're looking for when it's equal to 1/10 of its initial speed. So what is this initial speed? 4 meters per second. What is 1/10 of its initial speed? 0.4 meters per second. Right? So you're going to ignore this 2. Okay, go back to this function here. This should be v naught over v, by the way. I mean v over v naught. V over v naught, like so. I know that looks kind of weird because of the double slash, but you know the notation, it's fine. So you're subbing in capital T equals T, divide by negative k on both sides, right? You're going to have negative 1 over k times ln of, again, you can ditch the absolute values, 0.4 over 4, like this. And then k is 0.693. Solve for t, you are going to get 3.32 seconds. Okay? And now we need distance. How can we get distance? Now, if we look at our formula sheet, we do have this formula here, right? ADS equals VDV. ADS equals VDV. Very easy. Negative KV ds equals VDV. Just like that. The v's cancel, and you're left with negative. I'm going to write in the value for k now. 0.693 ds is equal to dv. Integrate from S1 to S2. We're looking for S1 to S2. Or you can also do, since we start at t equals 0 and it's moving along a straight line, you can assume that it starts at a position of 0. So that means when you're doing your definite integral, you're integrating like this, 0 to s f. But you can omit the f if you want to. So it would just be like negative k, because that's constant, like this. ds is equal v1 to v2, right? And again, it's 1/10 of its initial speed. So it would be v1 to v2. So 4 to 0.4. Because this is a negative, actually you can flip the bounds. So it's 0.4 to 4. Like, get rid of this negative. It's gone. That flips the bounds. Because originally the bounds are 4 to 0.4. But with the negative, you can just flip the bounds and do a regular integration. It doesn't really matter because the negatives cancel either way. Doing this, you get, of course, that S is equal to 4 minus 0.4, also known as 3.6. So I'll rewrite that as 3.6 over 0.693, which means S is equal to, finally, 5.19 meters. Okay? That's that question. That's done. So you can see, like, from all these questions we've done, you need to know trig. You got to know projectile motion. You got to know when to use the formulas, how to use the formulas. And you need to be able to, like, recognize things from reading the question. Like this, 1/10 of its initial value, right? You can see. Also, you need to know when you should be doing indefinite integration versus definite integration. Here is a very obvious definite integration because you're given two bounds pretty clearly, right? For the ADS VDV, you might not have thought to do that from 0 to S, but you should usually be starting from S equals 0 up until variable S. Same thing for, like, all the stuff, like V equals 0 to variable V. In these integrations, if you ever have something like this question. Anyways, on to the next question. I think we're on, like, Q6 by now. Yeah, Q6, which is this one. This is question 6. A projectile is launched from A, so we can point that out here, A, with the initial conditions shown in the figure. Determine the slant distance S, which locates the point B of impact. Calculate the time of flight T. Okay, so a few things here. We have two triangles. This is a triangle, by the way. This is a velocity triangle. These are not related triangles, by the way. This is a distance triangle. Like this. Those are our triangles. So we have the angle, okay, and we're trying to solve for this point B, which means we're going to need this height and this. Determine the slant distance S. Yeah. We only really need, like, one, either this or that, because then we just use trig and get S. Nice and easy question, right? So first of all, we will, of course, we'll work in the horizontal direction first, okay? Because horizontal is nice and easy. We're going to have to find, so velocity of x, looking at this, is going to just be cosine. So v naught x, we can get rid of the naught, by the way, because it's just v of x, is equal to angle, initial velocity 120, cosine of angle, which was 40. You can write this as a number. Leaving it as trig is fine, okay? You don't have to, like, write down a bunch of a decimal expansion. You can leave it as trig while answering questions. But in your calculator, don't have it as trig, okay? Don't have it as trig, because that would not be smart. Like, don't rewrite the trig every time is what I'm trying to say. That was a really wraparound way of saying it, but it's fine. It's fine. Now, okay, V is equal to D over T. V is equal to D over T. Okay, we're going to use that equation. Or, no, sorry, we're not going to use that equation. We're going to recognize that the velocity stays equal throughout this whole thing. So we have two sections here with equal velocities, okay? So we also need to get this here, which is S, right, adjacent, so cosine of 20 is our distance from here to here, and the velocity stays equal, right? So with that, we will just go S, this is all, I'm going to use X. X is equal to X naught plus vxt. Okay? Like that. Now we can change this. We know that x naught is 0. Okay? And we know that x is going to be from here all the way to here. Right? That is our x distance. So what is that? 800 plus s cosine 20. Okay? And that's equal to vt. What is vt? 120 cosine 40t. Okay? Issue. What's the issue? We have two unknowns. We don't know s, we don't know t. This is where we go into our vertical, okay? Our vertical projectile motion to get an answer. So we'll start with v naught of y. So I'm going to call it vy is equal to 120 sine 40. If you're weird, you'll do cosine 60. Don't do that because that's weird. I mean cosine 50. Yeah. And we need to get rid of an unknown, right? And how do we do that? T. We solve for time, right? We are solving for time. And we look at here, we have y is this, and this is y, right? We can get this for y. If we use this as our 0, and we ignore this upper part really, and just look at this part, just look at this part here. This is just going to be s sine, I ran out of room to write s sine 20, right? Nice and easy. So we're going to use our distance, and I'm going to stop flipping to the formula sheet, by the way, for like between things, because you should you will have the formula sheet. Well, okay, I can't speak on that. I don't know if that's true. Yeah, it would be nice if you get a formula sheet. I can say that much, but I don't want to keep flipping back to it every time to just show the same equation over and over. So we're going to be using our y is equal to y naught plus vy t plus half a t squared. Of course, a is 9.81, negative 9.81, because down is negative. Plug in some values. So y, what is y? We defined it as s sine 20, but remember it's negative because we're going down. Negative s, I'm going to put a capital there just to differentiate that. Negative s sine 20, okay, is equal to y naught is 0. V naught right here, 120 sine 40 plus or minus half 9.81 t squared. And I forgot to type out the t here. Now, we have two unknowns, right? We have t and we have s. There are two ways to solve this. And by two ways, I mean one way. Do substitution. Divide out by negative sine 20 on both sides, right? And then plug in s to this equation. Solve for t. Since it's a quadratic, you're going to get two values for t, by the way. You're going to get 3.04 and 19.50. These are both in seconds. You're going to be thinking, how does two answers make sense? It doesn't, okay? You need to verify your numbers. Plug 3.04 seconds into the original equation. And by the original equation, I mean just any equation. And check what distance it gives you, right? For example, if we plugged it into this equation, would you get a distance that makes sense? No? Okay, then that's wrong. Moral of the story, we're crossing out 3.04 as an answer. So I'm just going to cross it out. That's not an answer. It does not make sense in our equations. Okay, and the cross move. That's stupid. Anyways, 19.50 is our correct answer. Keep that in mind. I'm just going to erase that so that no one gets confused. 19.50 seconds is the correct time. You can also try to logic it. Like, if we look at this, you're launched at 120 meters per second, right? Let's assume it's a straight line. It's not. But assume you're moving 3 seconds, round down. 3 times 120. What's 3 times 120, right? 360. Is 360 more than 800? No, you're going to be like here in 3 seconds, right? So you don't even need to use the equations. You can logic it with your mind. You're going to be like, you're before halfway. You're not even halfway through the first section. But if you use 19 seconds, 19.5, I don't know what 19 times 120 is. If you do, good for you. But I'm sure it's going to be more than 800. Anyways, you plug that time into either equation to get S. Easiest would be to plug it into this equation, obviously. You're going to end up with S is equal to 1056.23 meters. Okay? So that is a nice question. I would say that one's actually a little tricky. Especially if you don't check the times, you could get screwed over by that. But you need to check the times. Always check the times. Anyways, we're going to be on to the last question, number 3, which I did forget to that's okay. Anyways, I did forget to grab like part A and stuff to write down. So I'm just going to write those down quickly right now. A is sketch it. So A is sketch. B is determine the velocity between for TA, TB, and TB, TC. And then part C is minimum runway length for the plane to stop. Okay. We're going to start with sketching. Okay. In the original problem statement, actually, we were given a pre-made graph template, but I'm just going to draw one out for you guys. Like this, like this. This is 0. Okay. This is all negative, by the way. This is 0 here. -1, -2, -3, and -4. This is acceleration, by the way. And then this is time here. This is the acceleration chart. And then we have, I'm not going to write T, TA, B, and C. Okay, and then we just drag these all the way up like this. And imagine this is a dotted line, which it should be, but whatever. I can make it dotted. Yeah, that's dotted now. Very nice. So, part A, sketch the graph. Now, remember for that earlier question, I brought up a table method. We're going to do that again because it just makes things easier to keep track of. There are 4 times that are important. 0, A, B, C. So 0, A, B, A, B, what? 0, A, B, and C. Okay, and then we need the acceleration, we need the velocity, we need the distance, just like so. And we need the time at the bottom. The time. So, let's read the problem statement now, finally. A small plane is landing on a runway at a regional airport. The plane hits the ground at t equals 0 seconds and moves with a constant velocity of 35 meters per second for 2 seconds. At TA equals 2 seconds, the pilot applies the brakes, giving the plane an instantaneous acceleration of -3.5 meters per second squared. Then, for the time interval TA is less than t, less than tb, the acceleration as a function of time is given by a equals t over 4 minus 4 meters per second squared. At tb equals 6 seconds, acceleration remains constant at -2.5 meters per second squared until the plane comes to a complete stop at t equals tc. Okay? So, anyways, this is 0, A, B, and C. Time, displacement, velocity, acceleration. Okay? This is also time, by the way. I know time is on here twice, but it's whatever. Initially, we have 0 displacement, 0 time, Zero acceleration, right? Because it says constant velocity. Remember, acceleration is dv dt. Derivative of a constant is 0. And this is just 35 meters per second. Now, at time A, we have a acceleration of negative 3.5, as stated in the problem. The velocity has not changed. The velocity has not changed. It remains 35. Distance is, I don't know, we have to calculate that. If needed, okay? Keep that in mind. If we need it, then we calculate it. And time is 2 seconds at A, right? B, time is 6 seconds. So it's 6. What is displacement? We're given it 184.7. 184.7. Okay? We don't know velocity. Have to calculate it. And acceleration is negative 2.5. Okay? And then again, from TC, the acceleration remains constant, right? For t greater than 6, it stays at negative 2.5. So negative 2.5. Velocity is a complete stop, 0. Distance, we don't know 0, and we don't know what TC is either. All we know is that TC is greater than 6. So we need to calculate, okay? Not yet though, because we can draw this graph. Acceleration starts at 0 for 2 seconds until A. And then it jumps down to negative 3. I should do a different color for this. And let's go pink. Okay. Acceleration starts at 0. It jumps down to negative 3.5. And then it builds up to negative 2.5 between A to B. Right? Because it's a function. All we know is that at time A has to be negative 3.5. And we can check that if we plug in t equals 2 into t over 4 minus 4, right? We get 1/2 minus 3 minus 4, which is equal to negative 3.5. Same thing if you plug in 6. 6 over 4 is just 1.5 minus 4, which is negative 2.5. Comes out to negative 2.5, and then it's constant from here. That's your graph, okay? Easily graphed. Easily graphed. Now we move on to, we need to fill out this table. We need to get V. Oh, wait, sorry. Yeah, this is V equals 0 because it comes to a stop. We need to find the velocity between A and B. So it would be this velocity, basically. And we need this distance. And we need this time. These are not the velocities between, by the way. I don't know what I meant when I said that. I meant to say that we need to find, using kinematics, we find these values, right? So, okay, so we need to calculate these values. S at this point A, right? So let's get started with that. S at A, okay? This is pretty easy. What information do we have for this point? Acceleration is 0. We have time equals 2. We have velocity equals 35, right? So we're just going to use the formula S naught plus VT plus half AT squared, right? S naught is 0. A is 0. So we're just going to have that SA is equal to 35 times 2 squared, which is equal to, or not 2 squared, I apologize, which is equal to 70. So we can plug this into our table here quickly. 70, and the color's changed, so you know what's like being added in. Okay, now we need our velocity at B, which is easily calculated as well. We have our acceleration. How do you get to velocity? Well, we know that A is equal to dv dt. So a dt is equal to dv. So we're just going to integrate t over 4 minus 4 dt, capitalized, equals dv. So do this integration, t squared over 8 minus 4t plus c equals v. We have t is equal to 2. We can take our initial, right? Here, we can start with our initial, right? For this, which gives us, so t2 is our initial, so we'll get 4 over 8 minus 8 plus c equals 35, right? Solve for c, it's equal to 42.5. Nice and easy. Now we go to our velocity at 6. So we're plugging in t is equal to 6. So v of 6, and recall this is a v of t function. I'll add that in. So v of t is equal to t squared over 8 minus 4t plus 42.5. Right, so v of 6 is equal to 36 over 8 minus 4 times 6, 24, plus 42.5, which is equal to 23. Very clean number. Add that into our table. 23. Okay. Now we have 2 missing values here. We know, 2 missing values. We got to find time and we got to find the distance. Okay. So we have an initial velocity, we have a constant acceleration, so we can use our kinematics equations. Okay, so we're going to go that v is equal to, this is vf by the way, v is equal to v naught plus at. But remember, t is delta t. So in all the kinematic equations, it's delta t. It's just you can usually assume it starts at t equals 0. Not in this case. Not in this case. So 23, or sorry, not 23, 0 is equal to 23 plus, or minus 2.5 in this case, tc minus 6. And we're solving for tc, okay? So you do plus 2.5, plus this term on both sides, divide by 2.5 plus 6, which gives you a tc value of 15.2 seconds. Write that in, 15.2 seconds. And now finally, the distance s, okay? Again, we're just going to use a kinematics equation here. We're going to have v squared equals v naught squared plus 2a delta s. And we're solving for sc. We have sb, right? And delta v squared is 0. This is equal to 23 squared minus, just to make it simpler, 2 times 2.55, right? We have sc minus 184.7. Yeah. Solve for this, which I believe, solve for this. You go plus 5 of this term, divide by 5 on both sides. 22 squared divided by 5 is whatever 529 plus 184.7, which gives you an SC, which is equal to 290.5. That's 190. 290.5, and I'm just going to round it. I'm not going to round it, actually. I don't want to. 290.5. Okay? And that is our table filled out. And now we get started on calculating everything for the question, which, I mean, we've already done, right? Part C was asking for minimum runway length, and, I mean, that was part D, sorry. Oh, I forgot. Okay. I forgot a C here. This is supposed to be D. C was find TC, right? I forgot to write that there. We found TC. We found the velocity between A and the velocity. Like we found these velocities that we needed to find. This chart's kind of in the way. You can read that. It's fine. And the minimum runway length we also found, which was just 291. So we solved the entire question while filling out this table. As you can see, the value. I'm just going to switch to yellow here. But as you can see, this value of 70 was useless. So there are ways to have known that we wouldn't need this value. Did it help? No, actually, it didn't help at all. we didn't need it at all. It was an extra calculation. No point to it, but that's fine. Calculating more stuff is fun or something. Whatever people tell you when they cope with bad exam grades is that they're having fun. We have all the values at all the different times. You got the time that we needed. Minimum runway length, we got. We got the velocity we needed. We were supposed to calculate this velocity, I believe, but like technically it doesn't really matter. I don't think yeah, there isn't like a way to actually know what this velocity is. Because the thing is, from here to here, yeah, it's from here to here. Yeah, it's a function. You can find the function for velocity. I'll leave that to you, actually. You can find that function on your own. But v of t from B to C, I'll write that. V from B to C is just negative 2.5 t plus 38. This is what you're looking for. That's your homework, if you can figure this out. Thank you for watching, and hopefully this was educational. Yeah.